Hello everyone, welcome back to the Math UMS class, week number 10. Today, we continue with the fifth lesson in the topic of polynomials, in which we will learn how to divide complicated polynomials, as well as how to apply the Horner's method to quickly calculate the quotient of a polynomial divided by a binomial x minus a. Okay, so let's begin our lesson today. In the previous lesson, we have learned how to divide polynomials by quite simple divisors, such as a linear polynomial. In this lesson, we will apply the same method to practice dividing some more complicated polynomials by more complicated divisors. Okay, so let's first consider this example: x to the power of 3 minus 3x squared plus 4x minus 2 divided by x squared minus 2x plus 2. Again, we divide the leading term of the dividend by the leading term of the divisor. X to the power of 3 divided by x to the power of 2. The quotient is x. And now we multiply x back with the divisor. X times x squared minus 2x plus 2. That will be x to the power of 3 minus 2x squared plus 2x. And now we'll bring that under the dividend and to see what remains now. We have negative x to the power of 2 plus 2x minus 2. We'll repeat the process. Divide the leading term of the dividend by the leading term of the divisor. Negative x squared divided by x squared gives the answer of negative 1. Again, we multiply negative 1 back with the divisor. Negative 1 times x squared minus 2x plus 2 equals negative x squared plus 2x minus 2. And now let's see what remains. You can see that the remainder is 0. So the quotient is neg x minus 1 and the remainder is 0. Quotient and remainder. Have you got the idea? It is very similar to what we have learned in the previous lesson. I hope that everyone will find it clear and straightforward enough to understand it and be able to practice right away. One more example. This time I want to divide x to the power of 4 plus 4x to the power of 3 minus x plus 1 by x to the power of 2 minus x plus 1. In this case, you can see that one term is missing. The term x to the power of 2 is missing. So we have to put 0x to the power of 2 in the dividend here, like this. Again, we divide the leading term of the dividend by the leading term of the divisor. And the answer should be x to the power of 2. Multiply back with the divisor. X to the power of 4 minus x to the power of 3 plus x squared. Bring back to see what remains. We have 4x to the power of 3 minus negative x to the power of 3, and the result should be 5x to the power of 3. We have 0x squared minus x squared, so the answer is negative x squared. We bring negative x from the original dividend here so that we have enough terms to divide it by the divisor. 5x to the power of 3 divided by x to the power of 2. The answer should be 5x. We multiply 5x back. We have 5x to the power of 3 minus 5x squared plus 5x. and bring back to see what remains. We subtract this expression from this expression, and the answer is 4x to the power of 2 minus 6x, and we bring down 1 from here. We continue the process. Divide 4x squared by x squared. The answer is 4. Multiply back. See what remains. We have negative 2x minus 3. Now you can see that the degree of the dividend is now smaller than the degree of the divisor, so we cannot divide it anymore. And here is the remainder of the division. The quotient is x to the power of 2 plus 5x plus 4, and the remainder is negative 2x minus 3. Okay, have you mastered the skill of dividing polynomials by polynomials? Okay, good. At home, please try to take random polynomials and divide it. Now you know the algorithm. You can divide any polynomials you want. So you just have to pick randomly some polynomials. As long as the degree of the divisor is less than or equal to the degree of the dividend, you can practice dividing it. Okay. Now moving on to the next part. Oh, we have another example. Okay, I forgot this, sorry. Okay, before we come to the answer, I suggest you pause this video and try to find the answer yourself, try to divide it yourself, and come back to this, check whether you have the same answer as mine. Okay, have you got it? Great. Now let's see my answer. X plus 1, and the remainder is 0. So we have the quotient is x plus 1 and the remainder is 0. Is it the same answer as yours? Hope so. Next, x to the power of 4 minus 3x to the power of 3 plus 6x squared plus a minus 7x plus 5 divided by x to the power of 2 plus 2. Again, x squared. See what remains. Negative 3x. Negative 3x to the power of 3 minus 6x. The remaining is 4x squared minus x plus 5. And finally we have 4. And here's the remainder. Negative x minus 3. You cannot divide anymore, so this is the remainder of the division. Negative x minus 3. And the quotient is x squared minus 3x plus 4. Another example. I will just show you the answer. Okay. Have you mastered it? Now we can move to the next part. Honest method is a quick way to divide a polynomial px by a simple divisor x minus a. Note that this method is applied only for the division when the divisor is of the form x minus a. It doesn't work for the divisor negative 3x minus 3, for example, or 2x squared plus 4x minus 2. It can be applied only in the division where the divisor is x minus a. And now let's see how the method works. First, let's consider this example. x to the power of 4 minus 4x squared plus 2x plus 1 divided by x minus 1. Step 1. Write the coefficients of the dividend in order and fill the missing coefficients with zeros. Now first, I will fill the missing term x to the power of 3 with 0x to the power of 3. And we write coefficients of the dividend in order. You can see that the coefficient here is 1, 0, negative 4, 2, and 1. So we write 1, 0, negative 4, 2, 1. And remember to space the coefficients nicely. Step 2. Input the value a in the assigned position. Here is the assigned position. And we need to input the value of a into this. Note that we are considering the form x minus a as the divisor. So in this case, x minus 1, a is 1. So a is 1. And now we input 1 into the position of a here. 1. Now we are ready to go. Step 3. Perform the algorithm. 3.1. First, we bring down the leading coefficient of the dividend. Here we have 1 here. We'll bring down 1 of the coefficient. Step 2. We perform the calculation. We take the newborn. In this case, 1 is the newborn because we just bring it down from the dividend. The newborn times a is fixed as 1, and plus the next coefficient of the dividend. The newborn times a and plus the next coefficient here. We have 1 times 1 plus 0. 1 times 1 plus 0. The answer should be 1. And 3.2. We repeat. Actually, this should be 3.3. We repeat the algorithm until the end. We take the newborn 1 times a, which is 1, and plus the next coefficient, which is negative 4. So we have 1 times 1 plus negative 4, it is negative 3. So negative 3 is the newborn. We continue the process. Negative 3 times 1 plus 2. 1 times negative 3 plus 2 equals negative 1. So negative 1 is newborn. We will multiply that with the coefficient with a 1. 1 times negative 1 plus 1. 1 times negative 1 plus 1, it is 0. So this is the end of the process. And now we have a list of coefficients. The final step is to write back the quotient and the remainder from the numbers that we have achieved. How can we do that? The last coefficient will be the remainder. Note that because the divisor is of degree 1, so the remainder is always a constant. It is always a number. In this case, it is 0. And the remaining numbers are actually the coefficients of the quotient. The quotient's degree is 1 unit lower than the dividend's degree. So the quotient is 1x to the power of 3 plus 1x squared plus negative 3 times x plus negative 1. Can you see that? Because the dividend is of degree 4, so we know that the quotient is of degree 3. So we just put the coefficient into the positions of x to the power of 3, x to the power of 2, x to the power of 1, and the constant term. Can you see that? And we simplify it into x to the power of 3 plus x to the power of 2 minus 3x minus 1. And you can check whether we have the correct quotient by perform the ordinary division of this divided by this. I guarantee that you have the same answer. Have you got the idea of how this method works? It is a very powerful tool, I believe. Okay, let's consider another example. We divide this by x plus 2. In this case, note that x plus 2 is of the form x minus a. So a in this case is negative 2. Please do not be confused. Don't take a as 2. It should be negative 2. Because the form is x minus a. First, we bring down the leading coefficient 2. Bring down 2. And then take the newborn times a and then plus the next coefficient. Negative 2 times 2 plus 3. Negative 1. Continue. Negative 2 times negative 1 plus 3. That should be 5. So the newborn is 5. We multiply the newborn by negative 2 and plus the next coefficient 11 to have 1. Finally, we have negative 2 times 1 plus 5, 3. So this is the remainder of the division. The remainder, and this is the quotient coefficients. So the quotient is 2x to the power of 3 minus x to squared plus 5x plus 1, and the remainder is 3. Have you got the idea? Now, let's practice. Apply Horner's method to divide. Okay. This is a very new method, so it is okay, totally okay if you need to wind back the video and see the previous steps and try to copy the method and apply it to the calculations that I am showing to you in the screen, on the screen. Okay, pause the video and come back when you finished all 3 calculations. Have you got it? Let's check the answers. The quotient in the question A is x to the power of 3 minus 3x squared plus 2x, and the remainder is 0. In the question B, we have the remainder is negative 5, and the quotient is x to the power of 3 minus 3x squared plus 2x minus 1. And the final quotient is x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x plus 1. Interesting, right? Remember this calculation. You will meet this calculation again a lot in the future, I think. Okay, and that's how we apply the Horner's method to quickly calculate the division of a polynomial divided by a simple divisor of the form x minus a. Try to apply this. Okay, that is the end of the lesson this week. Hope you enjoy this and hope you'll find this method convenient, powerful, and come in handy in the future. Thank you very much and see you next week with a new lesson. Goodbye.